Section 2 is actually pretty similar to Section 1. Again, in Section 2, we're going to revisit the idea of what an exponential function looks like, what its graph looks like, and also some of our transformations. So our first example here, I'll probably just do one example of this. We're going to graph something in the form y equals a times b to the x. So in section 7.1, we just graphed like y equals 5 to the x power. Now let's graph y equals negative 0.5 times 5 to the x power. Remember in section 1, we're talking about exponential form is y equals a times b to the x power. And a tells us what our y-intercept is, what our starting value. B is our rate of change, what we're multiplying by each time. So that knowing that will kind of help our graph make a little bit more sense too once we see what happens, what it looks like. So I'm going to start off by making a table of values. -2, -1, 0, 1, and 2. And for my table of values, I could do this a couple different ways. I could just take each x value and plug it in. That's probably the easiest thing to do. And that's what I'm going to do here. So take -2, plug it in here. 5 to the -2nd power. 5 to the -2nd power. Remember your exponent properties, that negative power makes it 1 over 5 to the 2nd, so 1 over 25. And then times -0.5. So I'm going to make that times -1/2. So that's a -1 over 50. So the point there is we have a really small fraction. A -1, plug it in. 5 to the -1st power is 1/5 times -1/2 is -1/10. So pretty small fraction still. When we actually graph this, we're really not going to see a whole lot of a difference here. Plug in 0. 5 to the 0 power is 1 times -0.5. -1/2. 5 to the 1st power is 5 times -0.5. And we could think of this as a decimal too. In terms of graphing, it doesn't really matter. 5 times -0.5 is -5/2. Or if you must, -2.5. This is a little bit easier to think about when we go to graph. And then plug it into 5 to the 2nd power is 25 times -0.5. 25 times -0.5 is -25 over 2, or -12.5. So let's graph this. On my graph paper here. So -2, -1/50th. And I'm just going to try to make that right below the x-axis. -1, -1/10 is still going to be right below the x-axis. So again, I'm really not going to see much of a difference here. 0, -1/2. 1, -5/2 or -2.5. And then 2, -12.5, so -10's here. Just going to extend my y-axis a little bit. This is right here. So when I'm connecting my dots, think about what's happening on the other end. Over here, it's pretty easy to see, okay, my y values are decreasing really, really fast. Over here, my fraction is just going to keep getting smaller and smaller and smaller. But we're still never going to cross the x-axis. Our y value is never actually going to get to 0. So we have the asymptote here. I guess the biggest thing to notice with this example is that our asymptote didn't change. Our asymptote is still at 0. And hopefully looking at this graph kind of makes sense. We have that negatives are reflection. That 5 to the x power, well, that's going to grow pretty quickly. Or I guess our rate of change is pretty big. This negative 0.5, well, the negative reflects, but the 0.5 is really a vertical shrink. So if this 0.5 wasn't here, our graph is going to be even steeper than what it is.